Um, okay, I think we are ready. So, and I hope you are ready too. We start a recording of our meeting, and also we have shared our webinar on YouTube. All links have shared will be shared in 2 minutes in our common group in Telegram. And I think we can start. And first of all, let me share my screen. Okay, great. So welcome to our webinar, to COEX webinar, and it will be 2 days of events. We started today and finished tomorrow, 2 hours per day, and today, day number 1. So let's get acquainted. And my name is Svetlana Solomatnikova, and I'm Drone Competitions and Activities Manager of Copter Express company. So I'm trainer since 2017, and also I was a chief expert at World Skills Kazan in 2019. Let me introduce Timofey Kondratiev, technical programmer of Copter Express. So let's welcome Timofey.
Hello, everyone. It's nice to see you again.
Yeah.
Yes,
Timofey,
I'm also
please,
a trainer.
Please say us some words
Since
about
2017, and I participated in some competitions, and I also prepared many participants to become a part of these competitions, and many of them became winners in mostly in programming of drones. So this is my primary topic that I will discuss today. And I hope I will teach you as well, and you will become the next participants and winners of other competitions.
Yeah, thank you, Timofey. So let's start. So, and before start, I would like to provide with you some rules of our event. So our event has a type as a webinar. So what does it mean? It is mean that it is a lecture. So we will give you all materials such as a lecture, and in the end of each day you will get a homework, and this homework will help you to upgrade your skill and repeat all steps. Yeah, and during the webinar, I will take off all sounds from your side. It will help us to make our conference better. So this is the first rule. The second rule, If you have a question during our session, please ask it in the Zoom chat. We will collect one-type questions and answer on it during our webinar today and tomorrow. And be ready to take a common photo. You can turn on your cameras and we take the awesome photos together. So this procedure we will repeat in start, in the end of our day, and finally we will compare your mood starting from now and at the end of our webinar. So I think you are ready to take an amazing picture. So what do you mean about it? Are you ready to turn on your cameras? I see many of you make a good hair and provide some makeup. Great. And really, I see your smile. It is a great power for our team, for me and for Timofey and for you, of course. So we take a photo in 3, 2, 1, smile. Great, just a moment. I will save your good mood and your energy in the start. And the second chance to make a awesome photo. 3, 2, 1, smile. Great. And one more. We have a 2 list of participants. Are you ready? 3, 2, 1, smile. Great, great, guys. Thank you. Thank you all. And before start, I see that Oleg Panfilyonok has joined us. And Oleg Panfilyonok, let's welcome. He's the CEO of Copter Express, and I think he say us some words. Oleg, welcome.
Yeah, hello everyone. How are you? Thank you, Svetlana, for introduction and for this webinar. I really like to present in this event, and I truly believe that it's important for welcome for new people to our community and share our ideas, our platform, our Clover Drone Kit and educational agenda to other people. So thank you very much for joining us and welcome to this webinar. And I hope you enjoy it and get new knowledges and learn a lot of fun things. And after that, realize it with Clover Drone in your future drone project. So go ahead and thank you very much and enjoy this webinar.
Okay, thank you, Oleg. And thanks for your energy power words. And now we start the best webinar. So you can prepare it some tea or coffee and be ready to learn new technologies. Okay, so first of all, I would like to provide the schedule or some agenda of our webinar. So first of all, I will talk you about us, about our company. Then we will talk about educational trajectory and international community. Then some words about webinar program overview. Next, Timofey will continue and provide with you Gazebo Simulation introduction. It will be a practice part of our first day webinar. And finally, we share with you the homework, and you will check your skill performing this task. Okay, so you know that drones, it's one of the most popular vehicles and devices in the world. And our company, Copter Express, we produced two types of drones for education and drones for industry. Educational drone, it's a Clover, and industrial types of the drones named Pelican. Also, our company produced drone points. Drone points, it's equipment for provide autonomous delivery. Our company was founded in 2013, and starting from these dates, we improve our products and share our experience for all. What area of application? Of course, you know that is really widely, starting from search and rescue, filming, and now the most popular, it's autonomous drones, such as a drone swarm and some task for unmanned cargo delivery and goods delivery, and provide different type of monitoring. But the main problem of widely area of application, it's really because there are not enough number of qualified specialists in the autonomous drones for development hardware and software. And in this case, we as a global partner, we provide some interesting system of education. We combined industry and educational institutions such as schools, colleges, and universities. And this system help us to provide permanently process of drone education. We provide training for teachers, students, and researchers, and it allows us to provide full integration, starting from education drone and up to industrial drones. Also, this system allows us to motivate universities and colleges provide research activities using our drone educational platform. We provide different types of events for different age categories, starting from 12 years old, and we don't have a upper level of age. But of course, the task is different between juniors and university students. One of our important historical moments, we start provide educational activity in 2016, and then in this year we have a focus on different type of drone application, included manual control, including drone development system, and it allows us to be closer for aerial robotics system. And now we have a focus on drone programming and provides the full development system of autonomous drones. In 2020, it was a really great year to transform our offline activities in online. And we will talk you about it some later, how we provide it. So our drones consist of open source technologies. So, and this platform, we use a Pixhawk system for flight controller and Raspberry Pi 4, such as a single board computer companion. This system are same for educational drones and industrial drones. So starting your education on Clover, you can get all skills for software and hardware development, and it will be similar for industrial drones too. But of course, it will has some difference for scale, maybe some functional, but the principles will be the same. Also, our open source platform supports Python language, ROS system, and block programming for school students, such as Blockly and Scratch. So using the COEX Clover drone, you can develop and learn your skill in assemble, such as the design engineering, soldering, 3D prototyping, problem solving, knowledge about electronic devices, and more. Skill in the flights, in the piloting, of course, it's FPV race, monitoring, manual piloting, and aerodynamics, of course. And the most popular trends of drones, of course, it's autonomous drones. You can start learn programming on drone using Python language and C++. Also you can use a computer vision system and robotic operating system on this platform. So now our community consists of more than 20 countries, and it's a really great step in our development, because many active members of each country provide a contribution in our open source system. They share with us their project, their knowledge, and their achievements in drone development. The interesting facts that our average age for our member community, approximately 23 years old, and in each year we become younger of it. So during the last year, we have many problems and have many questions about how to teach students during pandemic time and how to develop international community. And we developed the solution of it. We developed really online competition with not only using online tools, and also we use real equipment. We built the competition management center, equipped the flight zone and real drones, and we use online tools for communication, such as Zoom, Telegram, and YouTube. During these tools, our competitors took part on our events, such as BRICS and WorldSkills and online camps. They send the codes, and they saw how drone flight and performing their task. So it looks like on this slide. So you can see how our competitors perform the task on the simulation environment. Then they run the code on the real flight zone, named remote venue. And live stream was organized by YouTube. So this is a task was QR code development, QR code recognition. They should to recognize the data from QR code and perform the flight mission. I will open the secret for you. The system, the skill you will get on our webinar in 2 days. So, and also we provide some online training camp, and we will show you and demonstrate you how you can get a beginner skill in drone programming using only your laptop and our software. So we think that these tools, such as a simulation environment and practice on the real drone, give you fundamental knowledge of aerial robotics, and it helps you to reach the main goal. It's to create your own project in aerial robotics area using open source technologies and share your experience for other people. Many of our educational material you can start learn right now on our website. It is open and it includes manuals for assembling and setup, manuals for programming, information about competitions, and information about where you can demonstrate your project. Now I would like to share with you some interesting, one of the interesting projects or activities that we organize too. It's such as a copter hack. It's a drone. It's a hackathon for drone enthusiasts. The participants provide and demonstrate their ideas in this area. For example, drone control by hand with sensors. And on this slide, you can see many other projects, such as a face recognition system, charging station, copter spheric guard, and human pose estimation drone control. So description of each of these projects you can see on our website, on our Gitbook. This is our platform for education, and you can find more information about it, and of course use it. So join our community, and we are open to cooperation. You can write me personally, and we can discuss different ways of work together. So, and now I would like to give a word, to give the word to Timofey, and Timofey provide you some practice steps with Gazebo Simulation, and you will learn a new skill in drone programming. I hope it will be really interesting for you. Don't forget to ask any question in our Zoom chat. We collect your question and answer on it during our session, of course.
Yes, hello again. Let me start my presentation. All right, so this is our first day where I will teach you the basics of how you can work with Clover and how you can start today. Let's begin with what drones applications are the best drone applications that we are going to see in nearest future. So one of them is, of course, cargo delivery, which is a very great way to deliver important packages. For now, there are several projects on cargo delivery, including this one. Well, in our company, we also deliver a package delivery system. So it may help many people in the world to deliver very important packages in just little to no time. The other application is entertainment. So here is a drone show. All of the dots are real drones that are controlled by a program, and they make a beautiful shapes in the sky. So you can use it for, you can make some ads in the sky, or make just on holidays instead of the fireworks. It's more safe and very, very beautiful. The other application is the air taxi. Those are actually autonomous drones. So they look like they are manual controlled, but they are usually autonomous. So this is one of the application of autonomous drones. And also, drones can be used as firefighters and in rescue missions. So you can use them for many, many different tasks. Of course, there is entertainment such as, and sports, such as those drone racing. Drones are flying very fast, and people learn to master their skills for many years, and they become very good pilots and achieve these incredible results. And there's also a new wave of drone racing, is autonomous drone racing. So in the nearest future, you will also see races by autonomous drones. The agriculture is another application. So drones can be used for spreading some liquids on the plants. It is not just water, but water with some added things to make plants grow better. And it reduces costs of growing foods, and so this is a new industry that is rising right now. And how about Clover drone? What can it already do? So this is a small video that shows how you can program Clover for now. The drone is equipped with a camera that's here for navigation and for color recognition and shape recognition. You can use it as a positioning system, and if you have several drones, you can make a small swarm, the indoor swarm of drones. And Clover participated in many, in some international competitions, and it showed that this platform is very powerful, and you can achieve many, many cool results with it. So there's a aerial acrobatics of the drones. So you can see that the drones can perform autonomous flips. They can use computer vision to navigate through the environment, and you can learn how to program computer vision systems with the drones. Also, they can equipped with different kind of sensors, including this depth camera that makes a 3D scan of a person, which is another application of drones. And you can also deliver small types of cargo with it. Of course, this is just a simulation of what you can do in real world, but you need to start with something. And it's a good educational application of drones. So as you can see, the drones are also, they can be used in storage, in warehouses, and in theaters. So this is Clover swarm used in a theater. So they are controlled autonomously, of course, and there's a real performance with the drones. So this is what you can make with Clover. There are other applications, for example, the copter hack that Svetlana just told you about. And I can show you several projects that have been done with Clover. For example, one of the projects is the generative design frame. So you can use a Clover as a basement to create your own design of frames. And this project is just about that. They used the computer simulations to optimize the shape of Clover frame. And this is what happened, what turned out to be the optimized shape. Pretty much, it's pretty interesting in my opinion. And also with a protection. Another application, I can show you the video of this drone already flying. So you can use Clover as a platform to develop new types of drones. Another application is mapping and creating a map indoors. This is a project made by 3 students from Qatar. And they created this first in simulation, then they are transitioning to a real drone. They are making a map based on the LiDAR sensor that's put on a drone. And you can see that it creates a map, and you can use this map for planning the house and planning like a renovation projects and so on. And the drone is flying autonomously. There is a program that controls how the drone should move depending on the obstacles it's facing. And of course, another application is why not to use a paint on a drone? So you can put a paint on the drone, aerosol, to make like automatic paintings. Like few teams attempted this before, and one of the teams is participating in Copter Hack, which is nice. We want to see cool graffiti made by drones. It's so great. Okay, let's continue with our presentation. So our product has online documentation. You can access it by the link. What does it consist of? So first of all, it's remote controlled drone. You can control it with an RC controller. And it is made of the typical parts for the drone, like motors, electronic speed controllers, flight controller, battery, and frame. But the most powerful part of the drone is that it's autonomous, and it has onboard computer Raspberry Pi. Raspberry Pi is very popular small computer that usually runs Linux. In our case, it runs our custom-built Linux that has all the packages necessary for controlling the drone autonomously. And there is a camera and IR rangefinder that helps the drone know the exact height. And there's also a link for that. So what software does it use? Well, we try to always use open source software. One of the pieces of software is PX4. This is the software for flight controllers. We have a custom version of PX4 of this firmware, and that's just made for best experience with Clover. But you can use the default version if you set it up differently. Well, Mavlink is a protocol that helps flight controller communicate with onboard computer, the computer Raspberry Pi, and they are connected via USB cable. And ROS is like one of the biggest parts of software on the Raspberry Pi. ROS is a robot operating system. I will tell you a few more words about ROS after this slide. And the camera helps the drone navigate in indoor environment. So this is how it recognizes Aruco markers. Those are black and white markers that we usually put on the floor, and the drone knows its position based on that from the camera. Of course, we have a simulator where you can try all the stuff we're talking about, and I will show you how to install and use the simulator soon. So let me talk about ROS a little bit more. So we have in our knowledge base, it's clover.coex.tech. We have many articles that describe basic concepts of Clover. So what is ROS? This is a system that you can install it on your robot. It's usually installed on Linux, and it can, well, this will be used to connect all the different sensors and motors and other parts of a robot into one unified system. So in ROS, you have programs that can interact with each other by sending some certain types of messages, and each program in ROS is called a node. So it can be a Python script. And one of the ways to communicate between nodes is topics. So topics is like a data bus that will transfer certain type of data, and any node in the system can subscribe to this topic and use this data for its work. For example, there is a topic with images from camera. The other way of communicating is services. It's like a remote procedural call or something like that. You can call a certain function from one node, and this function will be performed on the other node. And we will work with it closely when we start programming. So for now, if you are not familiar with ROS, it might sound tricky, but it's not as difficult as it sounds. Okay.
Just a moment, Timofey. Could you make a increase font of Gitbook when you demonstrate it? Okay. Yeah, zoom in, please.
So like that. And also on this clover.coex.tech, you can find many more useful information about programming the drones. So there's also an example programs that you can start writing, and how to work with LED strip that you can program as well, and so on. Okay, let's continue with the presentation. So what are the positioning systems of the drone? If you are working outdoors, you have GPS. It's a good way of positioning. You can increase the precision of the system if you are using RTK GPS. It will allow you to know your position like with a few centimeters precision. This is very precise, but it doesn't work indoors. And indoors, you may use another type of navigation system like motion capture, but this is usually an expensive setup, and it's very powerful but difficult to use. You need several cameras and powerful machine to analyze the data, and you also have to have a very fast connection with all the drones that you are working with. So not very useful for indoor flight. And we are using the navigation system that is based on vision. So this is what you can put on your floor. And by knowing the positions of each of those markers, the drone can estimate its position in space. And this is what we use. It's the cheapest and easiest option that you can find. And you can also simulate this system in the simulator. So this is our simulation in Gazebo. You can see what it's capable of. For example, you can call ROS services from within the simulator, and the drone will take off automatically and do the stuff. And for now, it is working without Aruka markers. It is using optical flow system, another way of using camera to navigate around environment. Let me scroll a little bit. Yeah, so Aruka markers, they're recognized within the simulator, and you can navigate around them using ROS services. And also you can use the entire Aruka marker field to know exact coordinates of the drone and move around the field. All right, so how do you install the simulator? So this is what our next step is. First of all, make sure you have a powerful computer. It is better to have at least 8 gigabytes of RAM, because we are running a virtual machine. A virtual machine is another operating system within your operating system. So if you have 8 gigabytes of RAM, you need to have 4 gigabytes dedicated for your virtual machine, and you will have the rest of the 4 gigabytes left for your base machine. And it's better to have a good processor like Intel Core i5, i7 of like 5th generation and higher, and dedicated graphics card with at least 1 gigabyte of memory, and like 30 gigabytes of free space on your hard drive. Those are useful links on how to enable virtualization, which is an important step to work with virtual machines. And this is the link where you can download the VMware Workstation Player software that will run your virtual machine. And this is the link where you can download the image of virtual machine. So let me show you a few things now. If you open Task Manager and go to Performance, you need to make sure your virtualization here is enabled. If it's enabled, then you can install and work with virtual machine. If it's disabled, then you need to follow these steps from the video. All right. Let me assume that you have downloaded all the stuff and installed VMware Workstation and the image. So what you do next? This is my VMware Workstation player. And I need to open a virtual machine and proceed to the file that I've downloaded. It's size about 4 gigabytes. So I press open. I'll choose where will I install it. So it can be in D, drones, VMs, just a place where you will unpack all the containings of the virtual machine. And press import. Oh, it already exists, so you need to, in my case, I need to rename it. Yeah, press import. And it says it failed because of something. I'll just press retry and it will continue doing this thing. It will take like 5 minutes maybe, but I already have installed a clear version, so I will cancel this one. So once you install, you will see this thing. On the left, you will have a new installation of virtual machine, and don't play the virtual machine yet, edit its settings. So let's edit the settings. And I will first set the RAM. In my computer, it's 16 gigs of RAM, so I can pretty much use 8 gigs for the virtual machine, which is good. If you have 8 gigs, you can use 4. If you have 4, I don't recommend you installing the virtual machine on this computer, but it's still possible if you use like 2.5 gigs for your virtual machine. Then I will move to processors, and I'll use a half the amount of cores, the number of cores I have. I have a 6-core CPU, so I will use 3 cores for the virtual machine. The next is display. I will use accelerate 3D graphics, very important step, and use 1 gig of graphics memory. If you have less than 1 gig, you may have like this amount of, but I recommend you use 1 gigabyte. Then I'll go to options and VMware tools and press synchronize guest time with host. So your time on virtual machine will be the same as the time on your computer. It's important because otherwise the internet on the virtual machine might not work. Okay, press OK, and now I can play the virtual machine, and it is loading. This is my virtual machine. I can maximize the window. Let's give it a little time so it optimize the resolution. Yes, now the resolution is optimized. And you have installed the virtual machine. Congratulations. What is the next step? Let's test our Gazebo PX4. This is a link that will run your simulator. And now you can see that there is a field with Aruko markers, the drone, and it is ready to fly. On this line, you can see the real-time factor is like 0.98 and something like that. So it's running at 99% of the full speed. If it's slower, maybe it may be 0.5. It means that it's running in the half of the real-time speed. If you have a less powerful computer, you might face this real-time factor, which is not so bad, actually. It will work anyway. And the FPS here shows the number of frames per second. Okay, I've checked that everything is working. And now, before I will proceed, I need to do some settings to the Clover. So it is ready to fly, but it will not recognize markers by default. So I'll need to make sure they're recognized. This is why I will stop the simulation for now. So I will open the terminal that was opened when I ran this Gazebo PX4. And here I will press Ctrl-C. That will close the simulation. Just give it a time so it will close everything. Yes. And now I will go to Home, Catkin WS, SRC, Clover, Launch. So those are ROS launch files, the files that describe which nodes to run with which parameters. The basic launch file is clover.launch. You need to open it with Visual Studio Code and set the Aruko parameter to true. So this is actually an XML file that has all the parameters. Well, some of the parameters are in different launch files, but here is what I will change right now. So set Aruko to true, Ctrl-S and close. Then I will open Clover, then Aruko.launch. And here I will need to set true in the Aruka map and Aruka VPE. And one more thing is we need to specify which Aruka map we are going to use. So the default map is called map.txt. This is not the one that's installed in the simulator. So the one that's installed is called smit.txt. So this is what I've done here, cmit.txt, and Control S. And this is it for the configuration of the Clover to work with Aruka markers. I saved everything up and I can now run Gazebo PX4 and wait for it to load. Right. And how do we test our program? Let me show you some files, like programs that are predefined here. I've opened Home here and examples. So those are example Python files that we will try to run. So how do you run these files? I will open terminal here, right click, open terminal here, and write a command, Python, and let's use like flight marker.py. Flight, press tab, and let's maximize everything so we can see it clear. And run. The drone started rotating its propellers and takes off. And lands. Okay, so this is the program that we just ran. Let me see what you have inside the program. You can double click and it will open in the Visual Studio Code. Yes, and so this is a basic program. So looks like it didn't really fly to the spot it needed, but I will find out real soon what happened right here. But this is all what you need to write for your first program. Let me show you how to write it from scratch. So open the programming part of the Clover COEX stack. And here in programming is already an example, a piece of an example code that you can copy and use it for, you can use this code and modify it as you want. So let me do that. I'll copy this text, go to the virtual machine, and here I will actually create a new folder that will store all my new codes. So I will close this program and create this folder in Home. Let's call this codes. Yes, and in Visual Studio Code, you can actually run the Visual Studio Code from the desktop. You press File, Open Folder, and Codes. Okay. And here, if you click this plus button, you can create a program. Let's call it 1.py and Control V. So this is our program. What it does? Well, first it imports ROSPy and some other packages, like from Clover it will import SRV and trigger. Then it initializes the node name to be called flight. Then you have proxies to each service available. It will work like functions. So this is get telemetry service, navigate, and some other. And from here, you can call the services. Like navigate with X, Y, Z, frame ID body, and so on. After the break, we'll have a break soon. After the break, I will tell you what are frames and which ones to use. For now, let's try to run this program. You can run programs right from the Visual Studio Code. So I will Control S and open up the Gazebo to see what happens. Decrease the size of the window here, and here, if I press this green play button, the drone should take off and fly. Let's do that. The drone now takes off, goes a little forward, and lands. So this is our first program, and later we will modify it and do some other interesting things. So Svetlana, it is the time for coffee break.
So if our attenders ready to eat, we can do it. But before it, we have a question. So Timofey, I have received a question in personal message, but I will read it. So the question, can we code without using the virtual machine? As much as I understood, virtual machine is for the simulation.
Wow, you can write codes anywhere in any editor, but to test them, you need either a virtual machine or a real Clover. So you can write, but you cannot test it otherwise than with virtual machine or a real drone.
Yeah, but if you have a real drone, you can write the code on any compile system, such as in this example. So and run on real drone. But if you don't have a real drone, you should to use a virtual machine for run your code in Gazebo Simulation.
Okay, any other questions?
Okay, so yeah, we have a question. So do you provide the materials for us, or do we have to provide them ourselves? So what do you mean about materials? If you mean about materials such as a video recording or presentation, we will share with you at the end of webinar in our Telegram group. I have shared the link before. So now I think we can have a 5-minute break. Don't leave it this session. We provide a break time, 5 minutes, and then we will continue, and Timofey demonstrate with you features of the Gazebo simulation and how to write your first program. Okay, so we will start in 5 minutes. During the break time, you can write your questions in the chat. Guys, we will start in 5 seconds. Okay, so I see several questions in our Zoom chat. So the question about drone materials. So when we will finish program it, or it's only for program competition. So this webinar demonstrate you tools for learning skill in drone programming using only simulation. It is a great tool that will help you to provide debugging and check your code in the virtual machine, into virtual drone. Then that you get a correct result, you can upload your code on the real drone and run it. And the behavior of real drone and drone in simulation will be similar or will be different with tolerance approximately 5 or 10%.
I also see a question in Russian. It says, how similar is physical model of Clover in our real Clover and the simulated Clover? For example, if we simulate a flip in Gazebo, can it work in a real drone? Well, they are a little bit different, and flip in Gazebo will not work in real life, and vice versa. So a real flip that works on a real drone doesn't work in Gazebo usually. So difficult tasks like flips is better to test on the real drones, and you can rely on Gazebo, but you must know that it will not work exactly the same. Okay.
Just a moment, I see one question about using software on the in the different parts. So it's compatible with different parts of drone, but you should to provide additional setup using other components of drone, because if you will use other motors or other frame, you should to provide setup of PID controller by self, and it takes additional time and it's difficult. That is why we use ready to fly kits Clover for it. Yeah, so I think all questions was finished, and now I think we can continue. Timothy?
Yeah. Okay, I will continue the demonstration. Okay, so let me again launch the PX4, the Gazebo PX4, and I will talk briefly about what this Gazebo PX4 is. So basically, this link will run a software in the loop of the flight controller simulator. So there is a PX4 flight controller running on the machine. It's simulating the hardware. And you also run ROS with Gazebo. Gazebo is like a component of ROS. And also you run Clover packages that will work together to simulate the whole drone experience. And this is what you get from that. And let me show you some basic ROS commands. And what you can do with the ROS. So what is ROS node list? I told you about that every program in ROS is a node, and if you write ROS node list, it will display you all the nodes that are running for now. For example, there's a node Gazebo, a node Aruko Detect, Aruko Map. All of those are separate programs. And you can see which nodes are running if you learn what's inside the launch files. For example, if I open clover.launch, I will see that it makes some parameters like arguments, and then it includes another launch file like mavros.launch, and then it will call the node like web video server node. It says which parameters to use and some subparameters. Also, it will include aruko.launch if the aruko is true. For like you said, aruko is true in the beginning of this file, like aruko default true. And if it's true, it will run. It will include the aruko.launch. So it will also run all the nodes that are described in the aruko.launch. Otherwise, it will just not include it. Also, they have like nodelet for optical flow and like nodelet manager and some other things like simple of board, main camera.launch. It's also a separate node. So think of it as of a file. Like this file is also a node. If I run this file and let me just make a sleep for 15 seconds here, and you will see that the node flight will appear in the list of nodes once I run it. So this name is the name in ROS system, the name of the node. I run this program and I will ROS node list again, and I see flight here. So it's working. Once this program closes, the node will not appear anymore. And I told you like there are two basic ways for nodes to interact with each other. One of them is topics. Well, any node can publish data to topics and read data from topics. And if you have a node that publishes topic, this topic will appear in the list of topics. If you write ROS topic list, you will see a whole list of topics that are available right now. You can see the data. Oh, I think it's a small text. Let me make it a little bit bigger. So those are all topics that are available. For example, there is main camera image role and like Aruko detect debug and many other topics. Let me show you one of them. If I type ROS topic echo / range tab, rangefinder and range / range, it shows me the data from this topic in real time. So this is field called range. It says 0.04. Well, it stands for 4 centimeters. And if I take off with the drone and switch to this window, I will see the range will increase. Here it's 0.6 already, 0.4, 0.3. So it shows us that the rangefinder is working, and it shows us the exact distance measured with it. I press Ctrl+C to exit this topic, and I will show you image topics. It's very interesting to see. Well, image topics are topics with the message type image, and you can look at them in browser. For example, if you run Firefox here and type localhost/enter. This is a local website that is on the Clover. And if you open View Image Topics, you see this list of topics that are available for us. Let me open the Aruco map debug. And this is a small image already, but it doesn't show us anything specific unless I take off. And let me change the height of the drone to be 2 meters here instead of 1. And let's run this program and switch back to the browser so we can see this topic change. And this is what we get. It shows us how it recognizes all the markers, and it shows us the axis on this field. And the drone is already has landed. So, but we saw this image topic data. There are others like map image. You better, I recommend you use snapshot instead of just map image. So this is the topic where you can see the image of the map that's in the memory of the Clover. So this is the map that the drone is trying to find with this camera. Okay, let's proceed with services. So services, this is a list of services that you can also use. Many of them are mostly for internal use, but some like set velocity or set position and navigate, they are for our use as users. And once a program, a node says, so I have a service, it gets registered in the ROS service list, and you can access the service from wherever you want, even from the console. So for example, if I want to use the service navigate, I will type ROS service call /navigate space and tab. And it has basic parameters that I will change. First of all, I will change auto arm to true. Arming means to run the motors. Then frame ID. Frame ID is this coordinate system that we are working in. So if you type body, it will start its the 0, 0, 0 position from the position where the drone is right now. Let's have a speed of 1 meters per second. Then use Z as 2 meters. Once I press enter, I will switch back to Gazebo and see what is going on. Well, nothing is going on. Well, let's see. It said true, but didn't do anything. Let me try again.
Clover was tired.
Hmm?
Clover was tired.
Yes. Sometimes, oh yeah, I see the problem. Sometimes a problem may occur in the simulator in Gazebo, so you can restart it. I press Ctrl C here to exit the simulator and run this command again once I restart it.
Yeah. Oh, Timofey, could you zoom in the font of terminal view?
It will close now, so I will not. Okay, I'll run Gazebo again.
No, I mean terminal view, zoom in the font in the view and provide zoom in
Yeah,
of
this is
this
okay.
window.
Is this okay?
I think it's you can zoom in 10%, for example, or 15.
Like this?
Yeah, it's better. Thank you.
Okay. Okay, let me run the same navigate again.
Yeah, guys, it's a really great life hack from this life hack works on each problem. If your program doesn't work, try to restart any system.
Well, it didn't help actually. I will restart it again. If it won't happen again, I will restart the whole virtual machine. So let me try it again, because this time it couldn't connect to the flight controller. Well, it happens sometimes, so be ready for that. Well, this is in development right now, so I'll check if maybe I've changed anything wrong in here, but looks like everything's fine. All right, I will restart the simulator now, so I will continue after that. And so for calling service from console, you need to write our service call space / and the service name. Okay, let me restart the guest. Yes. It's not gonna take too long. Yeah, it's already restarted. I'll run Gazebo PX4. Let me check if there is no errors. I don't see any. And let's open a terminal. So for typing the comments, you need to use another terminal, not this one. So this one is already busy with other tasks. So here, if I type for service call / navigate tab auto arm through frame ID body and speed of 1 meter per second and the height of 2 meters. And now it is working. Yes, it is working now, and I can open again the Firefox so we can see localhost. Yes, this is it. Image raw will just show us the image. And optical flow debug. Well, optical flow is a system to stabilize the drone based on what it sees in camera, but it is not very precise. It just it detects if the drone changed its position and tries to go back. Not very precise, but works for environment where you can see some objects. And this helps to stabilize the drone. This system is working by default. All right. What are other service you can call? You can call for service call / G tab, GE tab. Yeah, get telemetry and tab again, and the frame ID arukmap. Enter. So this service returns us the current telemetry in the frame ID that we specified here. So you can see the X, Y, and Z position, the velocity along X, Y, and Z axis, pitch, roll, and yaw of your drone, and pitch rate, roll rate, and yaw rate, as well as voltage and the cell voltage, like the average cell voltage. So this simulator also simulates battery, but it will not drop after certain levels, so you can fly infinitely long in the simulator, unlike a real drone. Okay, let's land for now. You can also call the PX4 commands in this PX4 console. That is the one that starts with Gazebo PX4. Two most important commands you can use is commander takeoff and commander land. I use commander land to just land here. And if I want to quickly take off, I can type commander takeoff. And once again, it says yes. Now it will take off. And let's land again. Land. All right. So this is just for a quick test if everything is flying. For more specific position, you will need to use navigate. You can, with navigate service, you can go to any position here. So let me open up the Visual Studio Code again. So VS Code here. It still has open the codes folder, which is what I want. And our 1.py program is still here. So let me change something here. First of all, let's understand what to write in navigate. To take off, you need to first say navigate to certain height, like 1.5 meters is a nice height for the flight, and frame ID to use body. When you use frame ID body, it's like if you have this axis, wherever the drone is, the axis will be emanating from the center of the drone. But when you tilt the drone, the axis will stay vertical and horizontal. So they will not, the tilting of the drone will not change the coordinates. The other frame IDs are, let me show you where you can find it. So I actually have a good picture that shows what are other frame IDs. So there is Aruka map frame ID. This frame ID starts with the Aruka map. It's usually starts from the bottom left corner here, and X is looking there, Y is looking this side, and Z is looking up. So if you want to fly to this coordinate at the height of 1 meter, you need to provide X2, Y2, and Z1 to fly here. And we will fly to this position really soon. Maybe not this one, but instead to 3X, 2Y, and 1.5Z. The other frame IDs are map. Well, this frame ID starts from the place where the drone was turned on. And when you move the drone, it stays there. So the drone is moving in a map. It's changing its position in frame ID map. Basic. The map is the basic frame ID. And also you have navigate target, which I will explain you maybe tomorrow in more detail. For now, it's how to explain. For example, if I said to the drone, navigate to X, let me say X3, Y2, and Z 1.5 in frame ID Aruko map. Then if you, after you reached or after you started moving there, if you provide another navigate with frame ID navigate target, the coordinate will start from the point that you were previously heading to. So if the point 3 to 1.5 is here, the navigate target frame ID starts here. It's 0, 0, 0 will be here. So may sound tricky for you, but if you play with them, play around with frame IDs, you will understand. And you can open this, where is this? Coordinate system frames. Yes, there is a list of frames that you can use. With a little description. So let me continue with the program. Well, after we take off, we need to provide some time for this takeoff to happen. Like 3 seconds will be enough. What else is missing, in my opinion, here is the speed. I like to take off on higher speeds, like speed equals 1. Yes, and then 3 seconds will be just enough. After we've done taking off, we can fly to the other position and make sure you do not use auto arm true on the later navigate, because this is dangerous. It will lead to the drone going out of control if you try to overtake the control with the controller. Mostly for real drones, but you need to write programs similarly for the simulator and the real drones. Yeah, the question is, when the drone is using frame ID body, what information does it know and what sensors it actually uses? It uses the information that you can get from telemetry. Basically, the basic frame ID for getting telemetry is map. So if I erase it from here, it will show us this thing. And this is the information that the drone knows. Well, its speed is 0 and its position is around 0. And if you actually get telemetry in body, it will show us that its X, Y, and Z is just 0 straight without any numbers after the point. And so this is the place where the drone is located, and it starts moving from there to whatever the coordinates we provide. For example, if we provide like Z equals 2, it will look up for 2 meters and say, oh, this is my navigate target, and it will fly to that position. And it uses accelerometer, the gyroscope, and sometimes laser rangefinder, and sometimes the barometer, but it's turned off to estimate its position in space. So body is not very precise. It's good only for taking off, and I do not recommend you using body in any other situation than takeoff. So let's finish this program. I will set speed equals 1 here as well. And 15 seconds, well, let's see what happens if we give it not 15, but like 7 seconds, and then land. I press Ctrl S and open the drone. And let's now run the program. Make sure it's running. Yes, it's running. And the drone is taking off. And it is immediately moving to the position 3, 2, and 1.5. If we, well, yeah, it already landed, but if we tried to get telemetry while we were in this position, I will give it actually some extra time to hover, like 30 seconds. And this is important. One more important thing is, if we started from here, the drone will just take off and stay in the same place because it's already in 3, 2, and 1.5 coordinates in Naruka map. So if I run this program from here, the same program didn't change anything except for the time. it takes off and it will stay here. And now let's use some telemetry. Get telemetry with frame ID Aruko map. And look, X is almost 3, Y is almost 2, Z is almost 1.5. What if we use frame ID navigate target? Look here, the X is around 0, Y is around 0, and Z is around 0. So the navigate target is actually the target that the drone was heading towards before, like once we used the previous navigate. And if now in this program, I will use the coordinates 0 and 5 and 1.5, which is, well, it's easy to guess. It's 0 and 5, so it's around here. And I will run this program. Let's see. Takes off, and I will call the navigate target. It said it was like 2, -2, and 0 in these coordinates. But now if I run the same navigate target for get telemetry, I will have 0, 0, 0 because it already has reached its position. Another question was, is size type of cell Aruka map equals 1 meter? Well, in this particular map, the distance between the center of each marker is 1 meter. It could be any other distance if you wanted to, but in this case it's 1 meter. And it makes it easier to guess what coordinates are. One more thing is, if you have a distance less than 1 meter, the units you are working are still meters. So you will still say go forward to 1 meter or 2 meters and so on. Some examples are represented in code snippets. Yes, code snippets article. So you can play around with them. And also one very important article is simple of board that describes all the services that you are allowed to use, like get telemetry and navigate. So you can read what parameters are here in navigate, like yaw and yaw rate, which I didn't use yet. Navigate global and set position and some other. So it's here, programming simple of board. Okay, but as for me, it's not very intuitive way to write all the time how many seconds you need to wait for each navigate. Wasn't it better for the drone to know by itself once it has reached its point? Well, you can write a function that will do that for you, and this function is represented in the code snippets, and this is the first code snippet, and it's called fly towards a point and wait for copter's arrival. This is what I'm going to show you right now. And for the rest of programming, I will use only this function to navigate instead of manual navigate, because it makes it much easier to work. And let me just copy this function, as well as importing math module. I will do that here. So function, I will paste the function here, def navigate wait. And I will import math here. Right. Also, I usually like to change the default values for those 4 arguments. For those who are not familiar with programming or with Python, this is a function declaration where you decide what name of your function is and what the arguments are there. The arguments are parameters that can be differed, and it will affect the function work. So I will change the default z to 1.5, default yaw to 0, and default speed to 1, and default frame ID to arcomap. Now my navigate weight is ready to work, to run. So I will erase everything here except for the landing and use navigate weight with the parameters of frame ID equals body and auto arm equals true. And now the drone will take off automatically to the height of 1.5 meters. And once it has reached its height, it will proceed to the next navigate weight. So it makes it much easier to program paths. So there I have a question. Once we finish the code, where to upload it? In the Raspberry Pi, and it will work like what happened to the simulator. Yeah, you can upload. You can write the code right inside the Raspberry Pi if you use an SSH connection, or you can load it with some FTP software. And via SSH, you just write Python and your code name and enter, and it runs. Yes, this is how it works. All right, let me now create this program. So I said navigate weight to take off, then navigate weight and go to the 2 and 2 coordinates with frame ID map, of course, and so on. It is much less code to write. Let's see what happens if I run this program. And it is going here. So drone took off and then went here. How does function work? Well, the first thing this function does is it just calls the navigate, normal navigate, with the arguments, which are the same as the arguments, well, which with the same names, but those are actually different variables, as the arguments from navigate weight function. So here x goes to x, y goes to y, and so on and so forth. But we have tolerance here, which is not used in navigate. It will be used later. Here we have a while loop. While not Raspberry is shut down is the way to write loops that work infinitely in ROS or Python. So in the loop, we get telemetry, like with get telemetry service. And the frame ID is navigate target. I told you about that recently. You write this data to telem, and then if the squared root of squares of telemetry on each axis is less than tolerance, then break this loop. Otherwise, wait for 0.2 seconds. Well, this is actually a Pythagorean theorem, and you just calculate the distance between your current point and your navigate target. And once this distance is less than 0.2 meters, you break out of this loop, and you can now start another navigate weight function or anything else. And if you want to hover for some seconds in the spot, you need to say rospy.sleep and hover. Let's hover like 10 seconds in the position. Let's give it a 7 and 0. Control S. Let's see. Okay, let's go. Run. it starts taking off. And it will go to 0, 1, 2, 3, 4, 5, 6, 7. It's going here. And it will hover for 10 seconds once it reaches here. And then it will land. Yeah, isn't it funny? I mean, fun. It's fun and easy to code. What if we add some obstacles here? I just clicked this cube on top of the center face, and I can actually edit its size and the position if I use the tools here. And to change its size, I use this scale tool. Okay, now I have a tall cube. I can Control C and Control V. I can move this one as I want and Control V again. Okay, and what coordinates are these cubes at? So this is like this space between the cubes is 0, 1, 2, 2.5x and 2y. Then this one is 4.5x and 2y. And this is 6.5x and 2y. And we can make a program that will run between these obstacles if we just navigate way to, let's first go to 0, 0 coordinate. If I keep it empty, it will go to this position. Then let's go to navigate weight 2.5 and 0. Well, if it's 0, you can just keep it blank. Then you can go to 2.5 and 3, then 4.5, 3, then 4.5 and 1. Okay, that will be enough. Just and then go back to the navigate.
Yeah.
Okay, save it and let's try to fly around the obstacles. Oh, just to make it more fun, let me put this right in the way of the drone, so it hit the drone. So the drone will hit this. Oh yeah. So the physics is working now as well. You can simulate the impacts and something like that. You can put more obstacles. Okay, I think this is enough information for today. I can give you some answers if you ask. Maybe Svetlana collected similar questions that I can answer.
So guys, this is a good time for your questions. We will finish in 10 minutes our webinar. But before we finish, we would like to answer for your questions, and then we will share with you your homework, of course. Yeah, Timofey, we have a question.
Okay, I see the question. Can it detect if it will hit something? Yes, if you put some extra sensor on the clover. For example, like I showed you the project with LiDAR. If you put a LiDAR on top of the clover, it will detect like 360 degrees around the drone, and you can use this information to know whether to fly forward or not. Or you can just add another IR rangefinder. For now, we have one rangefinder pointing down. If you add another one, you can point it in any direction. The session will be recorded. It's already streaming on our YouTube channel, and it will be available there.
Timofey, and also, so is there any code examples on the Gazebo file over? Is there or no?
Some code examples are stored in home examples, but they are very basic, so you can use them and make something more complex.
Mm-hmm. Okay. Yeah, we will share the recording of the session in our Telegram group. So please connect and join us on Telegram. It will. I have shared the link again. So guys, any questions to this practice lesson from Timofey? Okay, Timofey, I think we can go to the next. Yeah, great. So, guys, how are you? What about information for you? It was difficult, or it was easy, or it was enough for you? And also I don't see your faces on the cameras.
Great. Thank you, ma'am. Thank you.
Great, thank you.
Yes.
Oh, perfect. Oh, yeah, guys, you are here. Perfect. Great. Yeah, we see there some questions. So, questions about recognition color in QR. So QR code recognition will be tomorrow, but color recognition, it's a really big and difficult topic. And I hope we will provide a webinar of it some later, or maybe on our camp, but not on this webinar.
Svetlana, and they asked, we talked about Scratch and block programming, how to use that. Can I show it for right now?
Great, yeah, okay.
Yeah, okay, let me show it. If you run this localhost server, there is a block programming link, and once you enter this, it asks you, have you enabled Clover blocks in Clover Launch? I haven't. I need to enable it first. So let's go to Clover Katkin src Clover Launch and Clover.launch and enable Clover blocks. Where is that? Blocks here. Now it's true. Control S and restart the simulator. Once I restart the simulator, I will check it again All right, let's run Clover again. And let's see if block programming is working. All right, flight, take off, then navigate to point. Let's have it relative to markers map, and the coordinates 2, 2, 1.5 with a speed of 1. Okay, and let's try to run the program. Okay. And this is it. You can, I didn't put landing here, but if you put landing, then it will land. After I run it again, it will land. Yeah, this is it. And you can also export it as a Python program. Where is that? So yes, this is how it creates a Python program right out of blocks program. So you can write something simple in blocks and then convert it to Python right away and copy it and use it. Okay.
Okay, great. Thank you, Timofey. So we have a positive reaction on our Zoom chat. It is really good. I see one more question about the main purpose of this competition. So this is not competition. This is a webinar. This is a event for improving your skill and introduce you to aerial robotics area. And yeah, so the main idea of competition will be later, and more information about competition I will tell you tomorrow. But for now, I would like to share with you some information regarding for tomorrow. Just a moment. Okay, so what will be tomorrow? Tomorrow we will have this agenda. First of all, we will explain the homework. Homework will have 2 levels: simple and hard. Then we will continue our lessons, and Timofey will tell you about how to work with sensors on drone, and tell you more about computer vision system on Clover. And finally, we will tell you about next steps in the aerial robotics area. So we will tell you about our upcoming events, competitions, and projects. So the day will be interesting too. Okay, so next. Finally, I would like to remind you about the important information. First of all, connect and join our group on Telegram app. We will share all information with you on this group. You can use this QR code or this link. Then, to get a maximum experience of the first day of webinar, repeat all steps on your machine when you will perform the homework. So, about homework, I will tell you on the next slide. And if you will have any questions when you try to perform in homework or performing any task, ask the question on this Telegram group in our support group, but please use this hashtag, and also you can mention Timofey to ask him directly technical question on the common group. And some words about your homework. So this is a regular task of your first homework. First of all, you should to install and set up the Gazebo simulation. You can use this link. We will share the PDF file with you on our Telegram group, and you can click on this link and upload the file. Check your setup and settings using any example of the code, and then perform a flight mission. So you should to provide takeoff, then make a rectangle trajectory, and make the landing. You can share your result, such as a video screencast, in our support group. It will be good, and also you can ask the question about this task too. This is a regular task. And we have prepared especially for you the bonus task. So the bonus task consists of editing additional objects in your Gazebo world. So you should to create the box, for example, 3 items. Then provide the obstacle avoiding trajectory using only frame IDs such as Aruka map. And then before landing, you can try to perform the flip. Flip, it's a rotation drawn of their axis. You can find information about flip and also examples of it on our Gitbook. And finally, of course, share your result with us. It will be interesting to see how you perform it. Any questions about the homework, guys? Are you ready to perform it?
Yes, I am ready.
Great. Your motivation in this difficult task, it's more important.
Sonnenstädten, I am ready.
And finally, I would like to share with you our common photo. So this photo we have a talk in the beginning of our webinar, and now I suggest to repeat this procedure. You can turn on your cameras. We take a photo again. And then we say goodbye to each other. So are you ready? Are you ready to take a photo. Yes, I see many smiles, many faces. Great. So 3, 2, 1, just smile. Hey guys, I love you. Great, perfect. This is one of my favorite part of any event. It's happy people who have got the complex information about autonomous drones, and they are ready to accept this challenge. So, and let's start the second chance of take a photo. 3, 2, 1, just smile. Great. Okay. And so, guys, I think we can finish our meeting for today. I was really glad to see you and introduce with you. Also, we are waiting your question in our Telegram group chat or personally, if you will have it. And see you tomorrow, guys. Thank you for your efforts, and of course, thank you, Timofey, for this interesting tutorial.
Thank you. Bye.
Bye.
Sağ olun.
See you tomorrow.